Welcome back to another explainer. Today, we're diving straight into the absolute chaos and the technical elegance behind the massive applications we interact with every single day. If you're a focused learner looking to truly master system design, you're in exactly the right place.
So, let's start with a big question. Ever wonder how companies like Amazon, Netflix, and Spotify handle mind-boggling amounts of global traffic without crashing every 5 minutes? Well, their secret is that they don't build one giant, fragile application. They build intricate networks of microservices. It's incredibly high stakes, and today we're going to explore the advanced architectural patterns that make it all possible.
We've got an awesome architect's toolbox lined up for you today. First, the microservices architecture shift. Next, directing traffic and discovery. Then building resilience against failures. Mastering distributed data. And finally, how you can actually level up your career with these concepts. Let's get right into it. Section 1. The microservices architecture shift.
Moving right along to Section 2, Directing Traffic and Discovery. Okay, let's dive into this. When you've got a massive, complex network of independent services, how do they actually talk to each other without causing a giant traffic jam? Well, enter the API gateway pattern. It's a real game changer. This gateway is essentially your central entry point for all incoming API requests. Think of it like a reverse proxy, a smart middleman, if you will, that beautifully decouples your clients from the microservices underneath. So instead of a mobile app trying to manually memorize the exact addresses of the shopping cart, the discount service, and the catalog, it just talks directly to the gateway. The gateway abstracts away the whole shebang, effortlessly handling dynamic routing, enforcing security protocols, and managing rate limiting.
But wait, behind that gateway, how do the services actually find each other? That is solved by the service registry pattern. Let's walk through the exact flow. Step 1. When services spin up, they independently register their names and endpoints with the registry. Step 2. The gateway, or even other client services, looks up those exact IP addresses right there in the registry. And Step 3. Traffic gets routed dynamically. What this means for us is absolutely no central control bottleneck and no hard-coded endpoints. If a service needs to scale up or move, boom, the registry updates on the fly.
Section 3. Building resilience against failures.
Look, here's the harsh reality of distributed systems. Things are going to fail. It's just a fact of life. So, to protect our apps from totally collapsing, we use the circuit breaker pattern. It literally works just like the electrical panel in your house. It's a protective safety switch. It keeps the whole application running by actively blocking requests the second it detects that an external service is failing. Say your payment service completely breaks down, the circuit opens and just stops sending traffic there. That stops one broken piece from dragging down the entire e-commerce site, giving the system a chance to gracefully degrade or flip to a fallback service. And keeping with the protective theme, we've got the bulkhead pattern. Yep, this one takes its name straight from actual ship construction. You know how ship is divided into watertight compartments, or bulkheads? So if the hull gets breached, water only fills one single section and the ship doesn't sink? Well, it's exactly the same concept here. We isolate our application resources into partitions. If one service gets absolutely hammered with excessive load, that resource exhaustion is perfectly contained right in its own little partition. The rest of your consumers and services just sail on smoothly without any nasty cascading failures.
Now for Section 4, Mastering Distributed Data. Honestly, this is usually the trickiest part of the entire toolkit. When you break an application apart, you're also breaking apart its central database. A massive lifesaver here is the CQRS pattern, which stands for Command Query Responsibility Segregation. The core idea is separating your command operations, meaning the stuff that writes data, from your query operations, the stuff that reads data. You put them into entirely distinct models with separate databases. Why go to all that trouble? Because in most highly scalable systems, the data models you need for complex writing logic are wildly different from the models you need for lightning-fast reading.
And this brilliantly illustrates how the separation works. On one side, you have the command model. This is strictly write-optimized. It receives commands and safely stores your data. On the flip side, you've got the query model, which is read-optimized and built purely to fetch and send data back to clients as fast as humanly possible. By pulling these concerns apart, developers can optimize and scale their read and write operations completely independently of one another.
Next up in the data toolkit is a really fun one, the event sourcing pattern. Instead of just overwriting the current state of your data in a simple table, event sourcing persists data by capturing every single state change as an immutable historical log of events. It's like a giant, unchangeable timeline. Take an e-commerce app, for instance. Rather than just saving a final shipped status, we store the entire journey,
Order placed, then item added, then shipment made. By replaying that event log, you can perfectly reconstruct the state of the application at any exact point in history.
Of course, there is no silver bullet, so we've got to look objectively at the trade-offs here. On the plus side, event sourcing gives you incredible auditability. I mean, you get a flawless historical log of all system changes, along with massive scalability. But let's look at the drawbacks. It definitely introduces a ton of architectural complexity. Plus, querying data can actually suffer from higher overhead, simply because the system might have to replay a bunch of events just to figure out what the current state is.
All right, finally, we have the Saga pattern for maintaining data consistency across a distributed setup. You see, when transactions span across multiple different services, you can't just rely on traditional ACID database principles anymore, those strict rules that usually guarantee safety in a single database. Saga solves this by executing a clever sequence of local transactions. And it does this in two main ways. You've got choreography, where there's no central orchestrator. Services basically just react to events published by other services. Or you have orchestration, where a centralized controller explicitly commands each service on what to do. The best part? If any step fails along the way, the Saga intelligently runs compensating transactions to practically undo all the preceding steps.
And finally, Section 5. Level up your career. Let's be real, mastering this exact architectural toolkit is exactly what unlocks the doors to top-tier tech companies. The source material for our data today actually comes from Boss Coder Academy, which is a fantastic platform dedicated entirely to empowering working professionals to master the exact system design patterns we just covered.
The numbers are pretty staggering. The data shows over 1,000 of their alumni have been successfully placed at top product-based companies. They are out there taking these complex, microservice concepts and turning them into massive, tangible career transitions.
And get this, the metrics also show a 136% average salary hike for working professionals in this tier. So mastering advanced patterns like CQRS or event sourcing, it's not just academic theory. It actually delivers a completely measurable real-world return on your educational investment.
So the crucial point is this. With an average package of 24 LPF for their alumni, the financial impact of stepping up your system design skills is crystal clear. The tech industry heavily values engineers who can step in and architect highly resilient, scalable systems.
Wow, we've covered an absolute ton of ground today, haven't we? From preventing those scary cascading failures using bulkheads to totally rethinking our databases with the Saga pattern. So I want to leave you with one final thought to ponder today. Which of these powerful patterns are you going to implement in your next system design? Take these tools, go apply them to your work, and build something incredible. Thank you so much for joining me on this explainer, and keep building.